In this section, we will learn about the different ways to implement loops in C. We will learn how to write loops and iterate over items using for loops, while loops, do while loops. So let's get started. Okay, so let's talk about for loops in C. As you can see in this example, I have a for loop here. So to write a for loop in C or C++, basically you use the following format. So you have the for loop as this. This is the for loop header, and this is the body of the for loop. You can have one single statement under the for loop. That's the statement that will be executed during the for loop, or you can have a body, a code block like this, where you have more than one statement. So let's dissect this and understand this more. The first part of the for loop is the initialization condition. So here you define the loop variable that you will be iterating over. So in this case, integer I equals 0. Notice the semicolon as if this is a single C or C++ statement. Also notice that the integer I is optional. You can actually define the integer outside and initialize it here. The important part here is the initialization condition, which is, having I equal to 0. The whole thing is also optional. You can move the whole thing outside, but you need to keep the semicolon in that case. This gets executed the first thing as number 0. It only gets executed once. Okay, so the next one is the test condition, which is the one that determines whether the loop should continue or should stop. As long as this condition is true, the loop will continue. The minute this condition is false, it will stop. The order of execution is, first the loop will execute this statement here, the initialization condition, then immediately it will execute the test condition, number 1, after this one, to make sure that this is valid from the beginning. Next, it will try to execute the body of the for loop. The code block is optional. If you only have one single statement, then that's also valid. Alright, so once the loop body is done execution, the for loop jumps immediately to the increment-decrement condition here, this last condition. So this is where you can say I equals I plus 1, or I plus plus, or plus plus I, in case of increment. There are some loops where you want to start from big numbers down to smaller numbers, like from 10 to 0. Then in that case, you might use the decrement operation here. So right after this is executed, what's going to happen next? It will go back and test the condition again, and then execute the body of the for loop, and then back again into the increment decrement. So as you can see here, the initialization condition done once, and from that point on, as long as this condition is valid, is true, it will continue from doing 1, 2, 3, 1, 2, 3 until the point where, for example, in this case, I is no longer less than 10. Then it stops and gets out of the for loop and continues down in the next statement in the code. Here I am on Visual Studio. Let's create a new project now using File, New Project. Click on Win32 console application. Let's call this one for loops. Hit OK. Next on this page. Make sure to select empty project, hit finish. Alright, let's go ahead and add a new source file using the add menu, new item, and let's call our source file main.c. Today we want to learn about using for loops. Let's get started. Let's go ahead and create a function called print timetable, and the purpose of this function is actually to print the timetable for numbers that we are given in as a number. So let's put a comment here. Alright, so how do we do that? Let's say printf timetable 4. Okay, so I'm gonna just print out a timetable like this. This is the part where we want to use our for loop. So let's say for integer I equals 1, we start from 1, I is less than or equal to 10 plus plus I. This is the initialization condition. This is the condition for termination or for continuation. As long as I is less than or equal to 10, it will continue the loop. This is the increment condition. Notice that you can do it as this, I equals I plus 1. That's one way. You can also say I plus plus or you can say plus plus I. Our for loop is going to be simple. We don't really need a code block. It can be just as simple as this: printf %d times %d equals %d. So we're going to say our number times I is going to be number times I. All right, so let's do it this way with a single statement just to show you the various ways we can write a for loop. Okay, so let's come here to main and call that function print timetable. Let's pass it the number 5, for example. All right, so now let's compile and run. Control F5. So now, as you can see, it's printing out timetable for 5, and it's showing us all the numbers from 1 to 10. Cool. So that's basically possible using the for loop. And now let's see how many ways we can actually tweak and change this for loop. The first thing, as I discussed before, is that we can take this thing out, the whole thing here, right? We can just put it in here. You can do it this way. And remember that if you take the first part of the for loop out, you have to keep the semicolon. Otherwise, it will not know if this is the first or the second part. So that's why we need the semicolon here. All right, so let's Control F5 this and see that, as you can see, there's no change in the output. So that's the first thing. The other thing you can do is you can actually just define the I here, and here come and say I equals 1. That's also valid. Let's run this. As you can see, same output. Okay, so that's another variation. This one we have to keep here. This one, like I said, we can say I equals I plus 1. That's another variation here. Same output. Nothing changed. It's just different ways of expressing the same thing. And finally, you can say I plus plus, right? Which is the same. Again, same thing. All right, so one other thing I want to mention here is that you can also say I plus equals 1, which gives you the same result. Or you can say plus equals 2, which is another thing you can do. You can actually make your increment not necessarily just by 1, by however you want. So let's say, for example, here, so you can see now I have a shorter timetable. It's only doing the odd numbers, right? 1, 3, 5, 7, 9. So because we're incrementing, I starts with 1 and we add 2 to it. Say we add 3 to it, for example, that's also possible. We will get a smaller table, and now we get this output. So that's how many ways you can do this. Another thing to notice is that if you don't do this here, for example, if we do it this way, then what's going to happen? Let's see what's going to happen. You can see here we have an indefinite for loop because I is never incremented. So this will continue going on forever and ever. So to break out of this, you can close the window from the X button here, or Control C on the keyboard to stop. So that definitely is important. You need to keep it. There's also the definition of an infinite for loop. An infinite for loop is defined like this. If you do something like this in here, this is called infinite for loop. This will go on forever. And because we have I defined outside, this is going to be uninitialized. Let's just give it 3, for example. Let's compile and run this and see this in action. As you can see, we have 5 times 3 going on indefinitely forever. So Control C to break out again. So this is called infinite loop. It never ends. So one thing we can do here actually is to do something like this. We can say I plus plus. If I is greater than 10, we can break. This is how you can break out of an infinite loop. You can use the break keyword with a for loop to break out of it. Control F5 to compile and run. As you can see now, we started with I equals 3. Once I has become more than 10, then the break statement takes you out of this loop. So you can use the break to break outside of a for loop or any kind of loop. You can also nest loops. You can have actually 2 nested for loops. For example, here we can say another for loop, for example, for integer j equals 1, j is less than 5, j plus plus. I'm going to do another printf here, which is j times I, just for fun. So now we have nested for loops, this for loop inside this for loop. Okay, so let's run this. And as you can see now, 5 times 3 comes from the first loop, and then there's an inner loop from 1 to 5, that's for j. keeps repeating itself every time, again and again and again, until we break out of the for loop. Alright, so that's it for the for loops. I hope you find this easy to understand. Please practice, play with it yourself, try it out, and then see you in the next lecture after that. Okay, so I have the code that we wrote in the previous lecture on the for loop. I just cleaned it up a little bit so that it is now back to the original code that we started with, where we print the timetable from 1 to 10 for a given number. Today I want to show you how to actually single step through it and understand it more. So the goal of this lecture is to just simply learn how to step through the for loop and understand how it actually operates more closely by using the debugger operations. Just to make sure that this is working right, I'm gonna hit Ctrl+Shift+B to compile on my keyboard and then Ctrl+5 to run it. Make sure that this is working as before. Okay, the timetable for 5. Now let's see how we can single step through this. I'm going to use the debugger this time, so I'm going to set a breakpoint on the for loop by hitting F9 key on my keyboard. So see, now I've got a breakpoint on this loop. So that means if I hit this button here to debug, or F5 on my keyboard, which I'm going to click now on F5, hit that one, and immediately, as you can see, there's this arrow here that says, okay, right now we're standing at this statement to be executed next. So F10 on the keyboard to single step. As you can see, it goes inside the loop code block and keeps going. And as you can see also down at the bottom here in my autos window, it is showing me the current value of I, the current value of number, which is not changing. I is showing in orange color because it just changed from the previous value. So this is kind of useful, but not very useful, because our goal here is to understand how the for loop itself works. So in order to make it more useful, I'm going to stop here, clicking on this stop debugging button on the toolbar, or Shift F5. I'm going to just say stop from here. I'm going to show you a way to actually make debugging for loop more interesting, but normally I don't recommend that you write your for loop like this. This is just for debugging and for us to learn. So by breaking it like this into multiple single rows like this, the C++ and the C debugger will actually help you out in stepping through these lines. So let's see that in action. Instead of F5, I'm going to click on this button here. As you can see, my code has changed, so it's asking me to rebuild. Yes, rebuild it for me. We'll rebuild and run. Alright, so now as you can see, inside the for loop, the first statement that it breaks on is this one, the initialization. You can see now here, by hovering on I, its initial value is garbage because it hasn't been initialized yet. It has been assigned memory location, but that's not been initialized yet. F10 on the keyboard, and now you can see if we go back, I is 1. Another cool thing is you can see here now, it's standing on the next statement, which is I is less than or equal to 10. So after initialization, test condition gets called next. You can actually do a nice trick here by selecting this without the semicolon. You hover on it, you can see now there's a small tooltip that says I is less than or equal to 10 is true. That means it's evaluating this for you. It's telling you that this is still true, which is good. That means we can continue. Now after this, when you hit F10 again to go to the next statement, it will go inside the loop body, which is this printf. So now it executes this. Once it's done, it goes back up to the increment statement. So now it's at this increment statement. Down below, I is 1. When I say F10, go next. Now I becomes 2. Immediately after the increment, it goes back to the test condition, right? It tests whether I is still less than or equal to 10. F10 again, it goes inside the loop. This is the code block inside the loop. F10 again, it goes to increment, test condition, inside the loop. Again, increment, test condition, inside the loop. Increment, test condition, inside the loop. It keeps doing that as long as the condition is met, is true. Right now I is 5. The value of I is 5. I'm going to continue until it reaches to 10. You can keep watching below as it's moving between the 3 in the same order I mentioned: increment, test condition, and then the loop code block. Alright, so now I is going to become 10. It's still valid. It goes inside, and then finally I is 10. Now increment I, it becomes 11. I is less than or equal to 10. That's no longer true actually. If I just come back again here, select this, hover on it, it says false. So now it's false. It's gonna break out of the loop, and that's how it's done with the for loop. So this is just to show you how to debug through the code using the for loop. And please don't write your for loops like this. This is just simply for testing. And I hope this was useful. See you in the next lecture. Alright, so today we're going to learn about the while loop. So let's create a new project, file new project. Again, it's going to be a C++ console application. Let's call this one while loop. Click OK, click next, and then here make sure to select empty project, hit finish. Now let's go ahead and add our main.c source file by clicking on add new item. From the Visual C++, we're going to click on C++ source file and just call it main.c to create a C, not C++ project. Click add. Okay, so today's topic is about while loops. Let's see how we can print the numbers from 0 to 15 by using a while loop, and then at the same time we will display their decimal value alongside their hexadecimal value. Let's call our function display hex numbers, and we are going to display the numbers from, let's put a comment here, display numbers from 0 to 15, both decimal and hexadecimal. Alright, so the way to do that using a while loop, we're going to create a while loop here like this. This is how you write a while loop in C and C++ as well. Make sure that it's all lowercase, and as you can see here, it's turned into blue because it's a keyword. What follows that is the condition that if it's true, it will continue doing the while loop. We're going to use a counter here, integer I equals 0. And so as long as I is less than 16, we will continue to do it. I++ printf %d equals %x. So I, and then I++. Alright, so what we did here is that we declare a variable called I, which is the loop counter, initialize it to 0, and we say while I is less than 16, if that's true, it will actually go inside the while loop. Printf, the value of I in decimal equals this value in x, which is the hexadecimal, and then we increment the I. If you forget to increment the I, then this loop will never end. This will be an infinite loop. Make sure to always increment your loop counter. So now let's see how we can call it from main. We're going to say just display hex numbers in this case. Ctrl F5 to compile and run. Alright, so now as you can see, it's showing us the values from 0 to 15, both in decimal and hexadecimal. Let's make it more interesting and see if we can just actually get more numbers. Let's say 32, for example. Ctrl F5, run. After 15, 16 equals 10, all the way to 25, then it becomes 1a, 1b, 1c, etc. So that's kind of how decimal and hexadecimal work together. Alright, so now let's see how we dissect this while loop. The first thing you notice, the while loop has a condition here. If this condition is true, then it will continue to execute. Once it's false, it will stop execution. So that's why we say I is less than 32, for example. The first thing it does when it comes here, it actually checks the condition. If at the beginning it's not true, it will actually exit. Let's say, for example, I initially is 40, right? Let's do it this way. We run now. We're not going to get anything on the output, as you can see. And why is that? That's very simple. If we put a breakpoint here and we hit F5 on the keyboard, you can see now, if you select this thing here and hover on it, it's false. From the beginning, if I hit F10 to step, it will immediately go out of the function because this was false, it didn't go inside. So that means that this has to be true for the while loop to continue working. Again, the while loop also can take one single statement like this. In that case, we can say I plus plus here and get rid of this I and make it just as simple as this. Let's put this back to 0. So it can actually be only a single statement here. So Control F5 to verify it's the same output. So as you can see here, it's the same, right, from 0 to 32. So really what you need is two things: a condition to be true, and that condition should always be true until you want it to exit out of the loop. There's other ways you can do this. For example, some people might say while 1 in here. That means in this case, this is always true. If I do it this way, let me show you. This is an infinite loop. If we run this, so you can see now it's going indefinitely here. Because I zoomed in, it stopped. But as you can see now, it will just keep going on forever. I'm gonna break with Control C on the keyboard. So that's an infinite loop. Another way to do this is you can say, like for example, constant integer true equals 1. That way you can just use the constant like this. By doing it this way, you're actually making your code easier to read, right? People can understand this more. You can find people that do this: constant integer false equals 0, 1 equals true, and then use it like that. In fact, Windows defines these in one of the header files, but we're not going to go into that now, but let's just assume it this way. So as you can see, the while true means it's an infinite loop. Let's see how we can break out of this loop if we do it this way. We can say here if ++i is greater than 32. Again, we can use the break statement here, right? So we can say, even though this is an infinite loop, we can break out of it under certain conditions. In this case, our condition is that if I becomes more than 32, we break. So that's another way to do it. Now, as you can see, it's going from 0 to 32. So that's pretty much it for the while loop. Please take the time to actually practice with it, play with it, and in the next lecture, we will talk about another form of loop called do-while loop. So see you in the next lecture. Alright, so today's lecture we're going to learn about a new loop in C++ called the do-while loop. So let's create a new project for that by clicking on File, New Project, and then from the Visual C++ template, pick the Win32 console application. Let's call this one do-while loop. Click OK. Click Next on this page, and then select Empty Project, hit Finish button. Right-click on source file, click Add New Item to add the source file. We will call it main.c, hit Enter. Okay, so I got a typical C program with the main function in it. So let's see how we can do the do-while loop. The do-while loop is usually in C as following. You say do, you open the loop, and you say while. And then you put the condition in here. So unlike the while loop or the for loop, you will notice immediately that this loop will always get executed at least once because the test condition happens at the end. So this is good in scenarios where you always want the output to at least show up once. And then here you put the condition whether you can continue or not. And notice that the while loop ends with a semicolon like this. So this is the do while loop. Let's say we have an integer I equals 0, printf I equals %d, print I, and then now we can say while I is less than, for example, 10. So let's try this one. Control F5 to run it. Also, as you can see here, it's an infinite loop because we forgot to actually increment our loop counter. So this is another infinite loop. So let's make sure that we increment I. Let's do that here, I++. Run again. Alright, so now we have from 0 to 9. Let's say we want to actually only print the numbers that are not even numbers. For example, we just want to print out the odd numbers between 0 and 9. How do we do that? There's multiple ways we can do it. For example, one way we can say if I modulus 2 is 0, then print it out. So this way actually, no, this is going to print out the even numbers. If you want to print the odd numbers, we say if it's not 0, that means there's always a remainder, then it's an odd number. So now as you can see, 1, 3, 5, 7, 9. So as you can see, this is one way to do it. Another way to do it is to actually start with 1 and then increment I by 2 without doing this. But I'm just showing you this to learn the do while loop. Okay, so let's try out another example. For example, let's say I want to do sum of some numbers, integer count. So basically this function here will return sum of numbers from 1 to n. Let's just call this n here, just for simplicity. So what we can do here is we can say now integer sum equals 0, integer I equals 0, do while I is less than n or equal to n. Then we can say sum plus equals I, then I plus plus. So this is the sum of the numbers from 0 to n. This should be sum, then return sum. Okay, so this function actually takes in a number n and it will find the sum of all the numbers between 1 and n, from 1 to n, including n. So that's why we say while I is less than or equal to n. We started with 0, we could have started with 1 as well, right? Because 0 is just not useful in this case. So now let's say printf sum of 10 equals, and then we say sum of 10. We run this. Now we can say the sum of 10 is 55. As you may already know, actually the sum itself, to verify that the sum of 10 is equal to 10 multiplied by 11 divided by 2. That's the actual sum here. You can say math sum of 10 equals s, and we can compare the two together. Alright, so the math sum and our sum are exactly the same. So I just wanted to show you an example to use the do while in here. So this is the do while loop. The only difference between this, like I said, and all the other loops is even if I say I is 100, right, and I put a breakpoint here, so even though I is bigger than n, it will still execute this at least one time. Let's see that in action. Hit F5 on the keyboard. As you can see now, we're inside the loop because do while it doesn't check this condition, even though notice here that this condition is false. It doesn't check it until later after it executes what's inside. So it will still do this, come out, and give you a sum of 100. This is just an example, right, to show you that the do while loop will at least at a minimum will always execute one time, whereas the while loop and the for loop may not run at all if the condition is not true from the beginning. This one can always run even if the condition is not true the first time. So that's the main difference. And that's it for the loops. See you in the next lecture. In this lecture, we will learn about the continue keyword in C++. So let's get started. Let's create a new project. Make sure you have C++ and Win32 console application selected. Just go ahead and call this continue keyword. Click OK. On this page, click next. And on this one, make sure to select empty project and then hit finish. Right click on source files, add new item, and let's call it main.c. Okay, so today we're going to learn about the continue keyword. Let's start with a simple example. Let's do a for loop for integer I equals 0, I less than 100 plus plus I. Let's go ahead and print out some numbers. So I want to say printf %d I. However, I don't want to print all the numbers. I just want to print the numbers that divide by 3. So if I modulus 3 equals 0, that means it divides by 3 without any remainder. Then we print out that number. Let's see how this simple example actually compiles and runs. Ctrl F5. All the numbers from 0 to 99 that divide by 3 are now displayed. Let's reduce the numbers further by using the continue keyword. So if any number of these divides also by 2, I'm not going to print it out. So the way to do that, we can say if I modulus 2 is 0, continue. So just a simple example to use the continue keyword. So continue here, what it's going to do, it's going to see if the number divides by 2. It will actually short circuit this loop and then goes back here. We could have combined the condition with this one, but I just want to show you how to use the continue keyword. So basically that's what the continue keyword does. It skips this iteration, goes back here, and then goes to the next one. Let's run this to just see the output. Control F5 to run. And now as you can see, we have a lot fewer numbers than before. So that's because the continue keyword actually skipped out all the numbers that are divisible by 2. Let's see this in action by using a breakpoint. F9 on my keyboard to set a breakpoint here, and then click on this green button to step into the code. Okay, so now we're here, I is 0. If the remainder is 0, which is true in this case, look what's going to happen. It's going to go to the continue and then right away go back to the for loop, and now I is incremented and it goes to the next one. So that's the effect of the continue keyword. Comes here and then goes back. So now we're at 2. So since 2 divides by 2 without remainder, it's gonna come here again and execute this. So that's why it's gonna go back to the for loop again and jump to 3. So now I is at 3. You can click continue. Now that's the first value to be printed out, and then goes back here. I becomes 4, and then 4 is gonna cause it to continue back to the loop. So basically the minute it hits continue, it just goes back to the for loop. Same thing happens whether we use for loop or while loop, etc. So that's just how we use the continue. Let me stop this and show you the same effect with a while loop. The only catch with a while loop is that you want to make sure that you don't end up in an infinite loop. You always have to increment I. For example, we would increment I here, but if you do this, this will cause an infinite loop because I will not be incremented at the first time. It will always be 0. Goes back again and again forever. With a while loop or do while loop, unlike the for loop, you have to be careful. You have to make sure that you increment I before you continue. So let's Control F5 to run this. Okay, so now you see it's the same effect. Whereas if I just comment this out to show you where you have to be careful with continue with while loops and do while loops, you might run into this case. Control F5. So now my code is stuck forever between the continue and the while conditions, and that's never gonna end unless I have to exit out of this by Control C on my keyboard or by closing this window. Alright, so this is pretty much it for continue keyword. You only use it for certain cases where you wanna skip certain logic and go to the next iteration. It's probably more useful in more complex situations, but this is just a code example. I don't wanna make it too complex, otherwise it will be hard to understand the code. The whole goal here is to just focus on using the continue keywords. So that's it for this lecture. Okay, in this lecture we will learn about a new keyword called the goto keyword. So let's start by creating a new project from the File, New, Project menu, Visual C++, Win32 console application. Let's call this one goto keyword. Hit OK. On this page, click Next. And now make sure to select Empty Project because we want to create a C project. Hit Finish. Right-click on Source Files, click on Add New Item. Select C++ file, but make sure to call it main.c. Hit add, and now we have our main.c. Okay, so today we want to learn about the goto keyword. A good example to use is probably by using the division operation. Let's say we have two integers, a equals 10, b equals 4, and if I want to say printf a divided by b equals to a divided by b, right? This is just a normal simple application. Let's run this first. Okay, make sure it works. Alright, so 10 divided by 4 equals 2. I forgot the new line character here. Add the new line. Okay, let's assume that this is 0, right? Division by 0. Let's see now if we divide by 0, what's going to happen. Control F5. As you can see now, my program has crashed because it's caused a division by 0 problem. So in order to avoid this, there's many ways to avoid this. One of which is basically by doing something like this. If b equals 0, or b is not equal to 0, then we do the division, right? But I want to teach you today how to use a goto statement, so let's use that. If b equals 0, say goto stop. So there's no such thing as stop, it's just a label somewhere in our function here that we want to define. So let's define stop, and followed by the colon here. So this is how you define a label that you can use with the goto statement. Just gonna say cannot divide by 0. Alright, so let's run it. Control F5. As you can see here, cannot divide by 0, because what happened is that it found that b is equal to 0, and then it says goto stop label. So it immediately jumps the execution from here into the stop label and continues from that point on. So what happens if we have something that's not 0? Let's say 5. Ctrl F5 to run. You can see here 10 divided by 5 equals 2, cannot divide by 0. Why is that? What's happening is that execution continues just as normal. It just goes from here all the way to the end of the function. To avoid that, if we don't need this case, we can just simply say return in here, because we don't want our normal execution to stop here. Okay, Ctrl F5. As you can see now, this is the proper behavior. So this is it for the goto statement. It's used to jump execution from one location to another within the same function here. So the label has to be local to the function. You can have multiple labels in the same function, but this is just an example. The label has to have a colon followed the label name. It can be any name you want. Some people use capital, some people use mixed case, some people use only small. This is completely up to you, however you want to call it. The other thing I want to mention is that you might read or hear somewhere that goto statements are evil. Well, that's not always true. Goto in languages like BASIC, right? MS BASIC or GW BASIC, yes, it was a terrible idea because you could jump around the code. It makes it unreadable. Goto inside C and C++ is bound to the function it's in. It's not always recommended, but there are cases where it's really useful. And I'll show you in future videos where to use it and how to use it. And also one last thing I want to mention is that the compiler is very smart. It knows how to optimize your code regardless of how you write it. We have this something called the optimizing compiler inside Visual Studio. It's very amazing at actually generating from your code the best binary code that's possible from this code. So it's very smart. It knows how to generate a really good executable code. Right, so that's it for now. In this section, we will learn about the different types of arrays in C and how to use them. The goal of this section is to learn how to declare and use one-dimension and multi-dimension arrays in our C programs. So let's get started. So what is an array? An array is a set, group, or collection of data of the same type. C arrays are zero-based and they are fixed in size. The size cannot be dynamic. The first type is called one-dimensional arrays, also known as vectors. You can also define two-dimensional arrays, also known as matrix. And you can, of course, define multi-dimensional arrays. So a regular value is considered to be a scalar value. A vector is just a single dimension, one-dimension array. So a series of numbers. The matrix is usually a two-dimensional array. How to declare one-dimensional array in C? Typically, the declaration of an array goes like this. You define the type, the name of the array, and between brackets, you define the size of the array. For example, if you want to define an array of 5 integers, we simply say integer a of 5. So that gives you in memory a variable named a that contains 5 slots in it. And since this is a one-dimensional array, it's also known as a vector. These elements are going to be in memory exactly like this in sequence. So 4 bytes in this case because it's an integer, 4 bytes for the first element, followed by 4 bytes for the second element, followed by 4 bytes for the third, fourth, and fifth, etc. And the elements can be accessed using an index. So since an array is zero-based, the first element is going to be the element 0, element 1, 2, 3, 4. So think of it as always the size minus 1, from 0 to size minus 1. Right, how to initialize arrays in C? One way to do that is by declaring it and initializing it at the same time. So we can say integer a of 5 equals 10, 15, 20, 2, 3. This is just an example of numbers that will go inside the array. So this goes into the first element of 0, of 1, 2, 3, 4, etc. So the end result will be something like this. Each element will be assigned a value as we declared here in this initialization list. Let's talk about how we can access elements of the array. For example, how to read or access a value of an array element. So let's say we want to read element number 3, which is this one, right? So simply we can say integer b equals a of 3, or we can print it out or anything like that. So now in this example, b holds 2 as its value because it got that value from the array. So this is just an illustration of how that goes. So basically, b is another integer that holds the same value. It reads the value from a of 3, gets it into its own memory. So the second thing we want to talk about is how to modify write to a single array element. For example, in this case, I'm saying a of 2 equals a of 2 divided by 2. So initially a of 2 was 20, and now we divide that by 2, so we simply read it back, divide it by 2, and then assign it into itself, and the end result will be 10. So that's how you can write and read in a single operation. So now let's talk about two-dimensional arrays. How to declare a two-dimensional array in C. Again, just like single-dimensional array, you start with a type, the name of the array, and then between brackets you put two sizes in here. The first one is the number of rows, the second one is the number of columns. So since this is a matrix because it's a two-dimensional array, think of it as this diagram, right? How many rows you want in your array and how many columns. And these are the elements inside the matrix array. So we do that by saying, for example, if we want to use 3 rows, 2 columns, we say integer a of 3 by 2. So total number of elements is going to be 6, 3 times 2, and that's going to be the rows, this is going to be the columns. So now that we declared the array, how do we initialize it? There are 2 ways to initialize the array. In C, you can write your code as the following. Integer a of 3 rows and 2 columns equals to 1, 2, 3, 4, 5, 6. This is the number of elements. And actually what's going to happen is that it's going to be initialized to the first row first, second row, third row. The more clear way of doing this is by actually, just for the reader of the code, to do it this way. Integer a of 3 by 2 equals a set of sets, which in each row you have the number of columns. So this goes to the first row, second row, third row. The end result of this initialization is as following. 1 and 2 go into the first row, 3 and 4 go into the second row, 5 and 6 go to the last row. Remember that this is the row 0, row 1, row 2, and this is column 0, column 1. So that's how we initialize two-dimensional arrays in C. Okay, now let's talk about accessing the array elements. In the first example, integer a1 equals a of 0, 0. In this case, at row 0, column 0, that means this element is being assigned to a new integer called a1. In the second statement here, we're saying that put 10 in the element at row number 2, column number 1. So row number 2 is the last row here. Column number 1 is the last column here. So the end result is 10 is going to be here. Just to show you what happened, the first statement actually put into a1 the value of a00. 0. The second statement ended up replacing the value that was 6 in here by 10 because we write to that location. Okay, so that's pretty much all about two-dimensional and one-dimensional array. Let's write some code and discuss more details about the arrays in C and some other things that we learn as we write our code. Okay, so let's create a new project by hitting File, New Project. So we're going to create another console application. Let's call this one Arrays, and then click OK. Next on this page, and as usual, click Empty Project, hit Finish. Now we're going to add, right-click on Source Files, add New Item, and let's call this one main.c. Click Add. Okay, so today we want to learn about using arrays in C. Let's start off by declaring a one-dimension array. So integer a of 5 equals, let's say, 10, 20, 30, 40, 50. Okay, so that's how you declare an array. Let's see how we can actually loop through this array. Okay, and then let's print out something like this. Just print out the values on the screen. Let's hit Ctrl F5 on the keyboard to compile and run. As you can see now, each element is being printed out, its location and its value on the screen. Alright, so now let's do something a little bit more interesting. Let's try to add all the elements in the array together and print out the summation. So let's say integer sum equals 0, sum plus equals a of I. So now let's print out the result, just sum. Okay, we see we've added all the elements together and printed out the result. Let's now do something else. Let's try to do like find max element in array and print it out. And this time I'm gonna just shuffle the elements around a little bit. Let's say this is 20, 40, 10, 50, and this is 30. Something like that, right? So now how do we do the maximum element? So the first thing we want to do is we want to define an integer max equals a of 0, just assign it the first element for integer I equals 1, I is less than 5, plus I. And now we can say if a of I is greater than max, then max equals a of I. It becomes the new maximum. So now we can say printf max element found equals max. Alright, so now we simply assign the first element into the maximum and then loop through the remaining elements, and if any of them is greater than the max, keep that in the max and keep going on until we scan all elements, and that's how we find our max. So let's hit Ctrl F5 on the keyboard to test this. Okay, so now let's look at this. You can see maximum element found is 50. What if we, just for fun, put the first element to be 200 instead of 20? So that way, just to test our code, Ctrl F5 again, run. Okay, so now as you can see, the summation has changed. The maximum element found is 200. That's pretty much it for a single dimension array. In the next video, let's discuss how we pass arrays into functions and how we can turn these, for example, into functions. So let's do that in the next video. Okay, in this lecture, we will learn how to pass arrays into functions and learn how to turn some of the code we wrote in the previous lecture into functions that use arrays. So let's write some code and get started. Okay, so I'm gonna reuse the code from the previous lecture. So go to File menu, Recent Projects and Solutions. Make sure to select the one called Arrays.solution, the one we created in the previous lecture. In the previous lecture, we initialized and declared a single dimension array, and then we saw how to sum all the elements and print out the result, and also walk through each element and print it out on the screen. We also saw how to find the maximum element in an array and print it out. So today, let's see how we can turn these into functions. So how do we pass arrays into functions? Let's start by defining a new function called SumElements. Then we pass it an array. To pass an array, there's two ways to do it. We can say integer, let's call this array AR, for example. There's two ways to do it. One way is to do it like this. This has a simple problem. We are assuming that all arrays out there should have 5 elements. So by doing it this way, this code is actually not generic. It's just always expects the array to be of 5 elements. What if I want 2 elements? What if I want 200 elements? What if I want 1,000 elements? So this is really good in certain cases where you know you have to have an array of fixed number of elements. But in our case, summation should work for any array. So the other proper way to do this in C is by doing it this way. You can say integer array. The only problem with this is that we don't have a way to find out the size of the array. That's why we need to pass as a second parameter here the size of the array. Caller should be able to figure out in their case what array they're passing in, so they can pass as well the size. So given that, let's just copy this code. Let's copy it here and say sum all elements of an array. Here sum equals 0 for I equals 0. I is less than size in this case. Sum plus equals a of r. The name is a little bit different. By the way, we can just give it the same name. I just didn't want to confuse you. It doesn't have to be the same name as the array you want to pass in. It doesn't have to be the same. And even if it's the same, that doesn't imply it's actually going to affect the original element by having the same name. Okay, so we don't want to print here, we just want to sum all the elements and then return the sum result. All right, so by doing that, now we have created an array function that takes any size array. So now we can say integer sum equals sum elements of our array of size 5. Okay, so we don't need this anymore here. Actually, let me undo that. Let me just keep the two sums together. Let's call this sum1 and then integer sum equals 0. Let's print them side by side at the beginning. So sum comma sum1. I just want to show you that it should be the same result to verify that our code is working the same way. Let's see it side by side here. Sum of all elements in array 330 and the function sum is 330. So it's exactly the same. So now we can just go ahead and delete this one. Call this one sum. Get rid of this. So now we have written actually a cool generic function that can work for any size array. And even in this case, right, we can just simply say, just sum the first element, 3 elements, for example. We can even sum the first 3 elements. As you can see now, it's just adding up the first 3 elements, 240 and 10 equals 250. You can make it even more generic by passing in 2 variables in here, the start element and the end element, and that way you make it just generic for all cases if you like to. But for now, just keep it this way, just make it simple. Okay, so the next one I want to turn into a function is the print array. Let's do that as well, right? Let's say integer print array. We give it an integer array name and an integer size. It's going to be pretty much very similar code. We're going to just do this here inside. Make it like this. Now we can say print array, our array of 5 elements. So this is going to print the array, then print the sum. Let's Control F5 this. Okay, so now as you can see, it's printing all the elements of the array and then printing out the sum. Okay, cool. Right, so now let's turn the max into a function as well. Since we're at it, let's just make this into another function. Okay, so I'm going to copy the code. I'm just going to say here integer find max, given an integer array and its size. And this time I'm going to just use the same name, copy paste here. Just the only difference is I'm going to make this equals to size and return max. So just to make sure that this is clear, what we're doing here is we're saying find max in an array of this size. So basically we declare a local variable called max, initialize it to the first element, and then scan all the remaining elements. If any of them is greater than the max, it becomes the new max. And finally we return the maximum value we found. That should be our maximum. So here, now we can say, instead of using a local variable, I'm going to just say find max or a of size 5. So now by creating functions, see how the main function is clean and very simple to follow and very simple to read. Let's test this out by Control F5 to run. Okay, so the maximum element is 200. Okay, cool. That's it for this lecture. See you in the next lecture. Okay, in the previous lecture, we saw how we use the single dimension array. In this lecture, I'll show you a way to quickly figure out the size of any array you have, regardless of the size, and you don't have to hard code it. So let's see how we can do that in code. Let's start by opening the solution from previous lecture, which is under recent project and solutions, click on erase the solution. That's the one from previous lecture. Just to review what we did in the previous lecture, we wrote 3 functions, one to sum the elements, one to print each element out, and one to find the maximum. As a matter of fact, the print array, I by mistake put integer here. It's supposed to return a value, but in fact, this is a procedure, meaning it does not calculate any value to return to the caller. Therefore, it should be void. Okay, so today's lecture, we want to see how, instead of passing here an integer array of 5, we pass the value of 5 here every time. How can we figure out the size of the array? Meaning that how can we figure out that this array is actually an array of 5? Let me show you 2 things. The first thing is we want to do integer s equals size of a, then integer, let's call this s1, s2 equals size of a of 0. So the size of a is going to give us the array size in bytes. Size of returns the size of an object in bytes. Let's do also s3 equals size of integer. We can also do that. So let's print out all three sizes, s1, s2, and s3, just to see how this thing is going to help us. So now that we have s1, s2, s3, let's try to run this and see what values we get from each size. Size of the array, size of the first element, and size of integer. Ctrl F5 to run this. Okay, now as you can see, s1 is 20, s2 is 4, and s3 is 4. s2 is actually an integer because a of 0 is an integer. That's why it's the same size as this guy. So just wanted to show you that this is really an integer. Array is the whole array. Its size was 20, right? The output that was this is 20, this is 4. And that makes sense because 20 is 5 times 4, right? That's 5 integers inside the array. So, well, with a simple math, we can actually find the size of the array. So let's call it here integer s equals s1 divided by s2. So if we divide 20 by 4, we get 5. That's the size of the array. So typically, this is how we do it. We just say integer size, let's just call it size, equals size of array divided by size of array of 0, the first element, or any element for that same reason. So this is how we calculate the array size. I just wanted to show you how to do it here, and then this is the typical way to do it. And now we can just come in here. I don't need this anymore. We can just use size instead of 5 everywhere here. And we can still print out here printf array size equals, then we just give it size here. Alright, so let's run this and see it in action. As you zoom in, array size is 5 and all functions are still functioning properly because the size 5 is still valid, it's the same. Another thing I want to show you here is that the compiler is nice enough that if you don't want to know how many elements, you can just call it like this. And if you do this, first of all, you cannot do something like this, integer a of like this. You cannot declare an array without a size. Remember that arrays in C are fixed size. You have to give it a size. However, there's one exception, which is when you initialize it, when you declare it like this, the compiler allows you to do this because it will count the elements for you and it will allocate an array exactly to fit all these elements. So this is why this is a shortcut, only can be used if you initialize the array right away. Now let's run this again and verify it's still 5. As you can see, the array size is 5. It's still doing the same thing. Now I don't have to worry about keeping track of the size. For example, if I take out an element or if I add a couple more elements here, I just added 3 elements, compile and run, zoom in. Now the array size is 8. It just does it for me. But that's a really beauty of doing it this way. There are cases where you can't initialize the array. In that case, you have to basically give it a size. But in this case, the compiler gives it the size. And the other case where we're allowed not to pass it in is like this. But in this case, if you don't pass the size in, then basically you can iterate over the elements unless you somehow know the size, right? So, and you cannot do this size on this one here. Let's actually try it out on the print array just to verify, right? If I say printf size of array inside rent array equals %d, and if I come here and say size of our array A, this is supposed to give me 8 times 4, which is 32. Sorry, it's AR. So let's run this and see how much I get out of this. As you can see, size of array inside print array equals 4 because it assumes the name of the array as a pointer to the first element. We haven't discussed pointers yet, but in a future lecture, we will talk about pointers. The array name is a pointer to the first element of the array. So in this case, because the array is passed into the function, the C compiler doesn't know anything about it. This points to some memory location. this memory location, as far as the C compiler is concerned, it doesn't know the size of it. It doesn't keep track of it. So that's why this trick of size off only works whenever you actually have the declaration of the array in hand, and then afterwards you can use this trick of size off. So this doesn't work, so let's take this out. In the next lecture, we will discuss more stuff about two-dimensional arrays. So that's it for this lecture. See you in the next lecture. Okay, so here I am on Visual Studio. I'm going to create a new project today for the two-dimensional arrays. So click File, New Project. From the New Project window, select Visual C++, Console Application. Let's call this one 2D Arrays. Hit OK. Next, make sure you select from this page Empty Project. Hit Finish. Alright, so now right-click on Source Files, add New Item, because we want to add our C file. And here we're going to call it main.c. Okay, so today we want to talk about two-dimensional arrays in C. First thing we want to do is see how we can declare a two-dimensional array. Let's say, for example, I want to create an array of integers. So I come here and say integer a of 3 by 2, which means that I have an array of 3 rows and 2 columns. To initialize the array, there's 2 ways. Either here, when you declare it, you can say equals, and you start specifying each row. So let's say we have 3 rows in here, like this. If I say 0, 1 in the first row, 2, 3 in the second row, 4 and 5 in the third row. So because it's 3 by 2, that means it has 6 elements. 1, 2, 3, 4, 5, 6. People might actually do it like this on separate lines, just to kind of represent the actual array itself. Okay, so now we have the array like this, in this format. Let's actually try to print it out. We're going to do 2 loops, one that goes through each row, and then for each row we're going to go through each column. For integer j equals 0, j is less than 2, plus plus j. Okay, now let's say printf a of %d equals %d. Alright, so what we want to do here, pass it I and j, and then pass in a of I and j. And of course, let's print each one on a line of its own, or we can actually, if we want to make it look exactly like this, it's probably better to just add a space here. Once we're done with the whole row, each row is going to be printed on the same line. Let's not put a new line character here because I want each column in the same row to be on exactly the same row. And then once we're done, we can say here printf new line. So let's see this in action. Ctrl F5 to compile and run. So now as you can see, a of 0, 0, 0, a of 0, 1 equals 1, 2, 3, 4, 5. In fact, if we just don't display this, only the elements themselves, let's just copy this for now. Let me do this as following. To kind of show you the actual elements alone without the indexes. So this is showing you now 2 columns on each row, 3 rows, each one has its own column. So that's kind of exactly like this one here. So this is how we actually print a two-dimensional array. And that's how we initialize it. So that's pretty much it for two-dimensional arrays. And the next lecture, let's talk about multi-dimensional arrays. See you in the next lecture. In this lecture, we will talk about multi-dimensional arrays and how to declare them and use them in C. So let's get started. Okay, so let's create a new project by using File, New, Project menu, and then select the console application here. Let's call it multi-array, or whatever name you want to give it. Click OK, hit Next here, and then make sure to select Empty Project. Click Finish. Alright, now we want to add our source file by right-clicking on Source Files, add New Item, and let's call it main.c. Okay, so today's lecture is about multi-dimensional arrays. So just to recap what we learned in the previous lectures, there's a single dimension array like this, two-dimensional array, something like this, 2 by 3, for example. And now if we want to do like more than that, we can, should be A1, A2, A3, 3 by 3 by 3, for example. It doesn't have to be 3, of course, it can be anything, right? It can be 4 by 5 by 2, for example. So in this case, this is actually a multi-dimensional array, right? It's a 3-dimensional array. You can even go even further. Integer array of 4, you can do 1, 2, 3, 4 numbers. Right, so C actually is very flexible. It allows you to do as many as you want. It's just to show you that it's possible to do it if ever you run into a case where you need a multi-dimensional array. And of course, it doesn't have to be integers. It can be float. It can be char. It can be any type you want, right? This is just, I'm using integers just to simplify our examples. So that's how you declare them. Let's do something like this. Let's do just an example with a 3-dimensional array, AR of 3 by 3 by 3, just to make our lives easy. And let's say like we wanna integer I equals 0, I is less than 3. Let's just try it. And now we can say AR of I j k equals some number. Let's say here count plus plus. And then we can define integer count equals 0 here. And so that, let me just fix the code as I was typing. I wasn't paying attention here. Okay, so we have 3 loops and we assign a unique number to each cell in the array. And at the same time, we can also print it out because it will be the same loop to actually print out a of, and here we can say I, j, k, and then the value inside the element of the array. I need to put a new line character here. So this is how we initialize a 3-dimensional array. And let's run this to see how it works. As you can see now, a of 0. So it's just initialized to elements from 0 to 26. So that's how you initialize a 3-dimensional array. One thing I might want to show you here to show you how you can look at the array inside the debugger. Just to give you some more value, let's see how we can actually hit a breakpoint here, F9 and F5 to debug. Let's just step through this. And as you can see down below, it's changing the values. If I actually hover on this, as you can see, you expand it, it's showing you 3 arrays in here, 0, 1, 2. If you expand one of them, it's also got 3 in it. If you expand the first one, also got 3 in it. We have already initialized the first 2. The third one is still not initialized. If we step one more, then that will get initialized. Again, you can hover over it and see it, or you can actually click Shift F9 on your keyboard to get the quick watch window, which is kind of easier here, as you can look at it and see inside it. So this is like the I, the J, the K's in here. You can see this is the 3-dimensional array, and you can look at the elements. You can see because we're still haven't initialized everything, they still have garbage in them, but at least the first iteration loop, we successfully stepped through that from 0, 1, and 2. And that's how it looks like under the debugger here. Right, so that's pretty much it for multidimensional arrays in C. In this lecture, we will talk about character arrays in C, how they look like strings, and how they can be treated as strings, and what's the difference between the two. So let's get started. So to declare a character array in C, we just say char a of 5, for example. This will create an array, just like an integer array, of 5 characters in memory. Let's assume it's 1 byte per character because we're using the ASCII table set. So as you can see here, we've got the array. How do we initialize the character array in C? We can do this technique here at declaration time equals, just like you initialize an integer array. The only difference is that we're using the single quote for each character here. Keep in mind that this is not a string, this is a character array. And in a minute, I'll show you the difference between the two. So once we initialize it like that, we end up having an array like this, where each character goes into a single cell inside the vector array. Okay, so now let's understand a little bit more about strings. We discussed before that C strings are null terminated. The null termination character is 0, so each string in memory will have always a 0 following it. The code in C will understand that this is a string. You can treat a string in C just like a character array. Think of it as a superset of the character array. Not every character array in C is a string. Every string in C can be treated as a character array. Unless it has a null terminator, you cannot say it's a string. Okay, so let's go back to the same example. We define a string, we used quotation marks. In this case, just like a character array, the string in memory will have a single cell for each character. In addition to that, one additional terminator at the end called the null terminator. We use a \0 to indicate a null terminator. So the null character in memory is not going to be visible inside the string. So that's how strings look like. How do we declare a string using arrays? You can say char a of 6. Keep in mind that this time I'm adding an additional cell for the null character. So here I have 1, 2, 3, 4, 5, but last one for the null termination in the memory because you want to account for that. Now you can use this special notation where C will know that by looking at the quotation marks, it will fill up every single cell with the characters from here, and it will add the null terminator at the end. So this is how A is going to look like in memory exactly. Okay, so now that we understood the difference between the two, let's write some code and make sure we reiterate over this using some code. Let's create a new project here and call this one another console app. Let's call it string array. We will cover strings in more depth in future lectures, but just for now, I wanted to let you know the difference and the similarities between the two. That's why we want to do this exercise. Click OK. Next, select the empty project option, hit finish. Now add the source file here, new item, call it main.c. Okay. Okay, so let's discuss the character arrays and strings in C. Let's say char a of 5 equals, sorry, let's do the character array first. H, E, L, L, O. Okay, and let's do this way. Let's try to print using, if you remember, %s is for strings. We try this with the A first and see how that goes. This should not work because A is not a string, it's a character array. So printf, when it looks at this %s, it thinks that you pass it a string. What it's going to do is going to start with A from the first cell, keep going on until it finds a null terminator. We could be lucky and find a null terminator somewhere along the line, or we could run into some garbage and at some point your program might crash. Let's see that in action. Control F5. So as you can see here, it actually did print hello and kept looking for a null terminator, so some garbage in memory kept going on, and eventually I think it hit a 0 somewhere. That's when it stopped. There will be other cases where it may not actually find it and it could crash easily. So that's why this is not really a string, it's a character array. Let's see how we do the same thing with S. By using this notation here, we're assigning the hello as a string into the same kind of character array, but in this case, it will immediately end it with a null terminator. So let's see that in action. Control F5. As you can see now, hello. In fact, let's verify that in memory. If we put a breakpoint here, hit F5 on the keyboard. So now let me show you A. If we expand A, I think the debugger is smart because it knows this is of 5 elements. That's why it's actually showing me all the way to here. But it won't be like this. See, if I hover on this, this is a string. This is saying ... at the end because it's not a string, but it's trying to treat it as a string. However, if we do Shift F9, see the quick watch, still the quick watch is treating this as a character array. This thing is smart, but if we come here and typecast this to a string, and the string is usually a character pointer, if you don't understand this, that's fine. In the next section, we will start covering pointers. But for now, just see it as is. As you can see now here, if we force it to be treated as a string, it keeps going on until it found eventually at some location a null terminator. So, but anyways, I hope you get the idea that this is not the same as a string. This is just a character array. Another thing to keep in mind is that you can't come here and say a equals, for example, let's say another string hi. You can't do that. You simply can't do that. It's going to tell you expression must be a modifiable L value. That means the array cannot be modified like this. If you try to compile, will tell you this is an error, must be modifiable left value, which is not the case here. Even with S, it's not how you actually change strings. There's other ways to change the values of strings, but you can actually do it one character at a time. Let's just change the number 1 instead of E into I, for example. Control F5 to compile and run. This is allowed, right? You can do that. You can change one character at a time. We will cover strings in more depth and when we talk about the strings section, but right now I just wanted to let you understand the difference between character arrays and strings. Alright, so that's it for now. See you in the next lecture.